Hello everyone. So today we are going to discuss some question answer on the Fermat Little theorem. So please be ready with notebook and pen. We are going to do this question answer together. Okay, now first of all read this question. Here in this question it is mentioned that 7 does not divide A. 7 does not divide A means GCD of 7 comma A is 1. And as we know that 7 is a prime number, so we can use the Fermat Little theorem as well. Okay, up to here it is okay. Now we have to prove that AQ plus 1 or AQ minus Q1 is divisible by 7. So please note down this question. Now, since first of all we will write, since 7 is a prime, that is because you know that 2, 3, 5, 7 are the prime, since 7 is a prime number, is prime, and already it is mentioned that 7 does not A divide this A, it means that GCD of 7 comma A is 1. So by Fermat Little theorem, can we say that a to the power 7 minus k1 is congruent to 1 mod 7? Can we say this one, na? Hai. It means can we say that a to the power 6 is congruent to 1 mod 7? It means can I say that a to the power 6 minus k1 is congruent to 1 mod 7? Then can I use the formula of a square minus k b square, that is a to the power 3 minus k1 or a to the power 3 plus k1 is congruent to 1 mod 7. Why? Because I have used here a to the power 6 minus 1 can be written as a to the power 6 minus 1 to the power 6. And here I can use a to the power 3 square minus 1 to the power square, which can be explained as a square minus k b square, that is aq minus k1 or aq plus k1, this one. Okay. Now if something is giving you, wait, if one have been shifted here, then it becomes 0 here. Sorry, my mistake here. It becomes 0. So the product of two things giving you 0 mod 7, then can I say that either aq minus k1 or aq plus k1 is dividing 0 mod 7? This implies that either aq minus k1 or aq plus k1 is congruent to, that is divisible by 7. Okay. This is the same question which we have to prove here. Okay. Now please note down this by pausing the video. I'm going to do the question number 2nd. Question number 2nd. So we have to use the Fermat Little theorem, and we have to prove that 17 divides 11 to the power 104 plus k1 using Fermat Little theorem. This one. Now proof solution. Here you can see that 17 and the 11 are both are prime. You can see, but among which of two we will use for Fermat Little theorem, because Fermat Little theorem say that if a comma n is prime, then a to the power n minus k1 we can say that is congruent mod n. Okay, na? So you have to take the hint from this one, because if GCD of a comma n or a comma p is 1, then we can say that a to the power p minus k1 is congruent to 1 mod p. Sorry, p comma a, we have to put it, okay? P comma a. The second wala. Second to the power raised to the prime minus k1. Okay. So here it is mentioned that 11 to the power 104 is present here. It means that we have to use 11 as a. है ना? 11 as a. And so we can say that GCD of here GCD of 11 comma 17 is equal to 1. So using Fermat little theorem, can't we say that 11 to the power 17 minus k1 is congruent to 1 mod 17? Correct है ना? That is 11 to the power 16 is congruent to 1 mod 17. So here we have a power 16. 16 now, okay. But we have to reach here 11 to the power 104. Correct है ना? Okay. So how can we reach to the 104? Let me divide 105 by 16. Let me check whether it is a perfect divisibility or not. 2 5 ja, 2 2 ja, and 2 8 ja. 226 bar and 2 4 bar. No. It will not perfectly divide this one. So we have to think different, something different. Either we have to reach somewhat near to it using 16. So 16 6 and 96, I think. And 16 6 and 96. So can I do that? 11 to the power, sorry, 16 to the power 16. Taking 6 power on each of them. That will be 1 to the power 6 will be 1, which is congruent to 1 mod 17. Correct, na? This one. So it will be 11 to the power 96 is congruent to 1 mod 17. And now we have to check how much power we require to reach the 104. So if I subtract 104 minus 96, that is I require 8 more power. 8 more power. है ना? So here I have reached 11 to the power 6 is congruent to 1 mod 7, as well as I can extend this portion to here, and I require 11 to the power 8 as well, है ना? Here I have 16 power. So how can I reach up to the 8 power? So what you are thinking that how can we reach? So yeah, I have to reach to the 11, and 11 is congruent to 11 mod 17, and 11 square, that is 11 square, that is 121. 121 when divided by 17, and 17 7 17 49 119 17 7 no 17 49 119. So it will give me 2 mod 17 11 square. Now continuing this portion here, so 11 square is congruent to 2 mod 7, but to make 104 in 11 to the power 96, I require 11 to the power 8. So can I taking third power on of them, that is 11 to the power 2 to the power 3 will be congruent to 2 to the power 3 mod 17. That is 11 to the power 8 will be congruent to 2 to the power 8, that is 8 mod 17. ठीक है. Now considering this as a equation number 1 and considering equation number 2. Now what I can do from 1 and 2, can I say that from 1 and 2? Can I say that 11 to the power 6, 96 multiply 11 to the power 8 will be congruent to 8 multiply 1, that will be 8 mod 17. 2 to the power 3 and 2 to the power 8. Oh, sorry. I have done some mistake here. That is to make it 3, we have to make it 4. Because 4 to 8 होता है ना यहाँ पर ये. So here it will be 16. Sorry, my mistake here. We go over 16 here. That's why I was saying that why the answer is not coming here. 16 here. So it will be 11 to the power 104 will be congruent to 16 mod 17. So here 11 to the power 104 plus 1 we require now, plus 1. Now what we will do here, we will apply add plus 1 on both sides. So when you will add plus 1 on both sides, then 11 to the power 104 plus k1 will be congruent to 16 plus k1, which will be equal to 17, which will be congruent to 0 mod 17. This implies that 17 is dividing 11 to the power 104 plus k1. Hence, understood now? Please note it down. Then we are going to move towards the next question. Okay, let's move to the next question. Next question. Question number 3rd. If GCD of a comma 35 is 1, then show that a to the power 12 is congruent to 1 mod 35. So here it is given that a is in relation with 35 with the GCD. Here you can't apply directly the Fermat theorem. The reason is this: Fermat theorem say that when GCD of a comma p is 1, then you can apply a to the power p minus k1. No? But here you can't apply because it is not prime 35. So what you can say that, you can say that solution that 35 can be break as 5 comma 5 multiply 7. So if GCD of a comma 35 is 1, then GCD of a comma 5 will be 1, as well as GCD of a comma 7 will always be 1. When a is not dividing 35, then definitely a will not divide either 5 or 7. So GCD of any factor of 35 with a will be 1. Remember, okay, now this one. So if GCD of a comma 5 is equal to 1, then I can apply from Fermat theorem now. Here you can apply Fermat theorem. That is a to the power 5 minus k1 will be congruent to 1 mod 5. And here you can apply a to the power 7 minus k1 will be congruent to 1 mod 7. So this will be to the power 4 is congruent to 1 mod 5. And here a to the power 6 will be congruent to 1 mod 7. Here you can see that I have to make 12 here. So can I raise power 3 here? A to the power 4 to the power 3 here in this. That is a to the power 4 to the power 3. So here 1 to the power 3, which will be equal to 1 mod 5. And here I should raise power 2, because to make it 12 I have to raise to the power 2. That is this one. So here 1 to the power 2, that will be 1. That is a to the power 12 is congruent to 1 mod 7, and a to the power 12 is also congruent to 1 mod. Okay, sorry, here 5 was going on. 1 mod 7. Understood? So if a to the power 12 is congruent to 1 mod 7 and a to the power 12 again is congruent to 1 mod 7, so can I say that from equation number 1 you can assume this, and equation number 2 you can assume this, that is from 1 and 2 we can say that a to the power 12 is congruent to 1 mod 35. From 1 and 2 we get. You know this concept now, that is if A is congruent to B mod C and A is congruent to B mod D. So from both of them we can say that A is congruent to B mod CD, but the combination of this one. Understood now? Now we are going to do more question on this in the upcoming next videos. Till then, keep going on practicing. Bye bye.